We have another problem. This is an example of a uniform flow in an open channel. Computing the flow rate of a circular pipe with a diameter of 1.60 meters. When the depth of flow or when the depth of uniform flow is 1.20 meters. The pipe is laid with a drop of 40 cm for every kilometer horizontal distance. Pipe wall roughness is 0.014. So first we have to illustrate our problem. So our pipe is a circular pipe. Okay, so given are the diameter, you have 1.60 meters, then depth of flow is 1.20 meters. So since our diameter is 1.6 meters and the half full of this is 0.8 meters, so we can say that the 1.2 meters depth is at this point, so 1.20 meters. So your pipe is partially full. So this is the area of flow. We also have the slope, which is 40 cm per kilometer horizontal distance, and the roughness, that is 0.014. So here we have to convert the slope into meters. So you have 40 cm in meters is equal to 100 cm is equal to 1 meters. Then for 1 kilometers you have 1000 meters. So our slope here is equal to slope is equal to 0.0004. Then we have to find the discharge. Okay, so the flow rate, this is what we gonna find. Okay, so let's start to solve our problem. So I have to copy this one. Okay, so this is our solution. Okay, so we have here the diameter is, okay, you have 1.6 meters. First, we have to compute the area of flow. So this is your area of flow. Okay, that is your area of flow. So we have to compute that one. So what from in your geometry class before, you are going to solve the area of any shape or any polygon. So please review your geometry subject. Okay, so I have to make this, okay, this way. So this will be now the area of a sector and the area of a triangle. This is my beta. The beta there is the wetted angle. I have to divide also my triangle, and this will be my angle, and I will let that one as my theta. Then we have also this one. Since I divided the triangle into two, so I have let also the base of the triangle as x. So if I have two triangles, I have also 2x. Okay, so we can start now. The area of flow is equal to the area of the sector plus the area of the triangle. If you forget the area of the sector, we can compute by getting the ratio of the area of the circle to the area of the sector with respect to their angles. A sector is just part of a circle. If that is your sector with an angle of theta, okay, we can get the formula by getting the ratio. So we have here the area of the circle is to the area of the sector, which is equal to the angle of the circle. We know it is 360 degrees, or also equal to 2 pi. The angle of the sector here in the figure is equal to theta. So area of the sector now is equal to the area of the circle, or theta times the area of the circle divided by 2 pi. Since the area of the circle is equal to pi r squared, okay, pi r squared, so we have now theta times pi r squared divided by 2 pi. So area of the sector is equal to, okay, we can cancel the pi. What remains is you have 1/2 r squared theta. So this is the formula of the sector. For the area of our triangle, we have this. So for our triangle, we have this one. So the angle is theta. You also have your theta. This is your h. This is your radius. This is your x. We know that the area of the triangle is just equal to 1/2 times base times height. Our base here is equal to 2x. So you have 1/2 2x times h. 1/2 times 2, so this can be cancelled out. What remains is equal to x times h. We need to determine the x using x and h using trigonometric functions in the form of radius. So we have here sine theta is equal to x over r. So x is equal to r sine theta. Okay, we also have cosine theta is equal to h over r. So h is equal to r cosine theta. So we will substitute this to our equation. We have r sine theta times r cosine theta. So we have r squared sine theta cosine theta. But we will not stop here because we can still simplify our formula. This is using trigonometric identities. So in your trigonometry, we have this formula for the identities. We have, if you remember, we have sine 2 theta is equal to 2 sine theta cosine theta. If this is 2 theta, for the right side, it is only theta. We have to make this formula in the form of sine theta cosine theta by multiplying 1/2 both sides. So we have now 1/2 sine 2 theta is equal to sine theta cosine theta. So we'll substitute it to our formula. We have now area is equal to r squared times 1/2 sine 2 theta, or equal to 1/2 r squared sine 2 theta. So I guess we are already ready for our formula for the area of flow. So the formula, we will use that areas with the derived formula. We have there for the area of the sector, we have 1/2, okay, 1/2 r squared, okay, 1/2 r squared, okay. But the sector here in our problem, that is the angle is beta, so we have here r squared times beta, okay. Then we have to convert this into radians, so we have to multiply it by pi over 180 plus the area of the triangle. We have 1/2 r squared sine the angle there is, okay, you have sine 2 theta, okay, sine 2 theta. Now we can substitute, or before substituting the values, we need to compute the value of our beta. So from the figure, beta, so we have beta is equal to 360 minus 2 theta. Okay, so we have, okay, where beta is equal to 360 minus 2 theta. Okay, that here for the 2 theta, that is the area, that is the angle of our triangle. So the angle of our triangle is 2 theta. Okay, so we have now, we can, I guess we can determine the theta value because h is given. So okay, theta is equal to, okay, given, the theta is given, the h is given. Okay, again we have here 0.40, okay, 0.40, and for our radius is 0.8, so you have 0.80, and this is your theta. Okay, so okay, we can have cosine theta is equal to 0.40 divided by 0.80. So theta is equal to 0.4 divided by 0.8. Okay, and that is arc cosine. So that is equal to 60 degrees. For the x, we also have here for our x, you have sine theta divided by 0.8. So x is equal to 0.8 times sine 60. So sine 60, okay, times 0.8. Okay, you have 0.693. 693. Okay, meters. Okay, because our radius is in meters. Okay, so now we can compute the area of flow. So we have area. Okay, area is equal to, okay, this is our area of flow is equal to area of the sector. You have 1/2. No, we still have the beta. Sorry, beta. So therefore, thus beta is equal to 360 minus 260. So that is 360 minus 120. So the beta is 240 degrees. Then you multiply this. Okay, but we don't need to multiply it by 1 pi over 180 because we already have included it in our formula. Okay, but in getting the perimeter, we can also use beta in regions. So better to convert this to regions. So you have 240 times 3.1416, okay, divided by 180. So this is also equal to, okay, or 4.189 radians. Okay, so again, the area of flow is equal to 1/2 r squared. So you have 0.8 squared. Beta is 240 times k pi over 180, k plus 1/2 0.80 squared sine k 2 theta. Sine 2 theta, that is 2 times 60. That is equal to 120. Okay, so you have 0.8 squared, okay, divided by 2 times 240, okay, times 3.1416 divided by 180. So that is equal to 1.340. Okay, plus for our triangle, you have 1/2 times 0.8 squared times sine 120. So that is 0.277. Okay, so we will add 1.34 plus 0.277. So that is equal to 1.617 meters square. So this is our area of flow. Okay, for our perimeter, for the wetted perimeter, that is only, okay, for the wetted perimeter, that is the water or the perimeter, that the perimeter or the wall of that pipe that is in contact with water. So this is our wetted perimeter, the portion of the pipe that is in contact with water. So that is just also equal to the length of the arc of the sector. So if this is our sector and this is the radius, the length of the arc is just equal to r times theta. So for the wetted perimeter, that is just equal to r times beta because the angle of our sector there is equal to beta. So here R is equal to 0.80 times beta in radians 4.189. So 0.80 times 4.189, okay, that is equal to 3.351. Okay, that is equal to 3.351 meters. Okay, for our hydraulic radius, it is just equal to area over P. So area is 1.617 divided by 3.351. So 1.617 divided by 3.51 is equal to 0.483. 0.483. Since in this problem, we need to find our Q, so using Manning's equation, okay, you have Q is equal to 1 over N, area are 2/3, S to the 1/2. So you have 1, the N value is 0.014. Okay, 0.014. Okay, 0.014 times area of flow, you have 1.617 times R, 0.483 to the 2/3. S, for the slope, we have 0.0004. Slope is 0.0004 to the 1/2. Okay, so we will compute. Okay, 1 divided by 0.014 times 1.617 times 0.483, okay, raised to the power of 2/3, okay, times 0.0004 raised to the power of 1/2. Okay, therefore our flow rate is equal to 1.422 cubic meter per second. So this is now our final answer. So you need to encircle your final answer or box your final answer. Okay, thank you.